Alright, this is going to be the first of a couple videos going over the review. I'm looking at the first one here. It says use implicit differentiation to find dy dx at a given point. So they're giving us an equation, they're giving us an x and a y value. I always label these. And so we need to take the derivative on both sides in terms of x. I can show that with like d dx. So this would be 4 dy dx is equal to 12, because 4 times the 3, x squared. I don't need to write dx for the derivative in terms of x. And then I think about this like it's minus 4. And then I'm going to say that I'm going to use the product rule, and f is x and g is y. So when I'm looking at f prime, that's just going to be 1, where g prime is going to be dy dx. So if I'm doing the product rule, it's like f prime g plus g prime f. So it's like 1 times y plus x dy dx. I'm subtracting, let me go back to the blue, subtracting 4 times the y plus x dy dx. So this looks like 4 dy dx equals 12x squared minus 4y minus 4x dy dx. When we've been working on these, especially with the Khan Academy assignment, at this point we would have moved all the terms with dy dx to the other side of the equation and get some sort of dy dx is equal to some fraction with, x's and y's in the numerator and the denominator. If you have the values, and we haven't practiced these ones as much, it would be good to just substitute in at this point. Let me get the yellow and orange. So it would be good at this point to just replace the values that you know on here and just work with numbers. So like 4 dy dx. It doesn't look right. 4 dy dx equals, this is 12 times negative 2 squared minus 4 times 8 minus 4 times negative 2 dy dx, or 4 dy dx equals, this would be a 4 times the 12 is 48 minus 32 plus 8 dy dx. (48) minus the 32 is going to be 16. And when I subtract 8 dy dx on both sides, that's going to be negative 4 dy dx is equal to 16. So I'm going to divide both sides by negative 4 to get dy dx equals negative 4. So we've done a lot of examples with implicit differentiation, specifically where we're doing the product rule. You can do other rules, and I'm going to put out a couple where you might be asked to do the quotient rule and the product rule. And it looks more complicated, but honestly, when we're working on examples that give you a value for x and y, it's a lot easier to see how this is going to move when you can combine like terms rather than writing a fraction. I'm going to do the same thing with number 2. This looks like, if I do dx on both sides, 6x squared minus 4y dy dx is equal to, now in this example, what I would call f would be the x squared, x cubed. F prime is going to be 3x squared. G is going to be y cubed. And then g prime is going to be 3y squared dy dx. So this is like 4 times, and again, we're going to do the product rule. So 3x squared times y cubed plus, this is going to be x cubed times 3y squared dy dx. My left side of the equation doesn't change. 6x squared minus 4y dy dx is equal to, I'd write this out like it's 12. Now I prefer to write the x terms first, like x squared y cubed. And then this is going to be plus 12 x cubed y squared dy dx. Now I just need to go through, substitute in for x, and substitute for y. 6 times negative 1 squared minus 4 times 1 dy dx equals 12 negative 1 squared times 1 cubed plus 12 times, let's try that one. Plus 12 times negative 1 cubed times 1 squared dy dx. All right, negative 1 squared is going to be a positive 1, so this is 6 minus 4 dy dx on the left side of the equation. I wrote this a little sloppy, but this is negative 1 squared, so it's a positive 1. So this is just a positive 12. Negative 1 cubed will be negative 1 times 12 is minus 12 times 1 squared is still minus 12 dy dx. At this point, you can pick whichever side. I would probably add 12 dy dx on both sides. And, you could do it one step at a time. And I'd also subtract 6 on both sides. So I get 8 dy dx is equal to 6. Divide both sides by 8. Dy dx is equal to, they have 6 over 8. If you check for the answer in the back, it'll be 3 over 4. All right, I'm going to do 3 and 4, and then I'll probably pause this video here and work on the next couple. I goofed. I didn't want to give you guys the u substitution on this, but it does tell us what u is. So if u is x squared minus 2, du is equal to 2x dx. Now, I'm not looking for 2x dx. I want negative 4 dx. So I would multiply both sides by negative 2 to get negative 2 du is equal to negative 4x dx. So I can replace u with x squared, so it'll end up being u to the 5th. I have my derivative. Here, the last thing to do is to change the bounds. In this one, it's like x equals 1, and this is like x equals negative 2. If x equals 1, then u is going to be equal to 1 squared minus 2. 1 minus 2, u is equal to negative 1. And when x equals negative 2, this is negative 2 squared minus 2, 4 minus 2, this is 2. I'm looking at u to the 5th du. Oh, negative 4 du. So like times a negative 4 du. This is a constant I can pull outside of the integral. negative 4 times the integral from 2 to negative 1 of u to the 5th du, which would be negative 4 times u to the 6th over 6, evaluated from 2 to negative 1. If I'm multiplying by negative 4 and dividing by 6, it's like I'm multiplying by a negative 2/3, and this would look like negative 1 to the 6th over 6 minus a negative 2 to the 6th over 6. Negative 1 to the 6th is 1, so it's like 1 over 6 minus 2 to the 4th would be 2, 4, 8, 16. Times 2 is 32, and then times 2 again is 64. And I'm multiplying this by negative 2/3. Negative 63 over 6 times negative 2/3. That would make this 3 and a 1. Oh, I messed up. I should not have been writing these over 6. So what I was trying to show here is that 2/3 could be negative 4 over 6. But I was confusing myself. I should not be writing these over 6. It should look like 2 over 3, so I factor out the 6th. And then I'm just evaluating u to the 6th, so it's like negative 1 to the 6th minus 2 to the 6th. So this would become negative 2/3 times negative 63. These would cancel. And I get negative and negative would be positive. This would be 42. All right, I just want to double check this one. I feel like I'm off on something. No, I forgot they don't evaluate it. Oh, I think I know what I did. All right. I see the mistake. I'm going to back this all up. So, all of this was true. I was looking at the negative 4x dx. It should have been times negative 2 du, which would make this look like negative 2, the integral from negative 2 to 1 of u to the 5th du, which would then become negative 2 times u to the 6th over 6, evaluated from negative 2 to 1, or negative 1/3 times 1 to the 6th minus 2 minus a negative 2 to the 6th, or negative 1/3 times a negative 63 to get a positive 21. All right, I'm going to do probably the next one in the next video, and then a couple more. I'll make a couple more videos tonight, and I'll post more videos tomorrow.